Okay, one more projectile problem. And this is more of an application, I think. It's page 72, number 23. It says, suppose the kick in example 3.4, which I'll read in a second, is attempted 36 meters from the goalposts, whose crossbar is 3 meters above the ground. If the football is directed correctly between the goalposts, will it pass over the bar and be a field goal? Show why or why not. If not, from what horizontal distance must this kick be made if it is to score? Okay, so we need to go back to example 3.4 in the textbook, which is on page 62. It says a football is kicked at an angle of 37 degrees with a velocity of 20 meters per second. So this is what's happening. You have an object kicked at 20 meters per second from the ground at a 37 degree angle. Further out, you have goalposts that are 36, I believe, 36 meters away. There's a goalpost, and the goalposts are 3 meters high. Okay, so we're trying to clear the goalpost here, but this is 3 meters above the ground here. Okay, so basically what's happening here is you need to know, you can't just say, oh, well, does it make it to 36 meters? That's not really relevant because it could hit below the goalpost. It needs to clear a height of 3 meters when it's 36 meters away. It needs to be at least 3 meters off the ground. So this is kind of an interesting example. So what I'm going to do is first set up horizontal and vertical like always. Okay, in the horizontal direction, delta x, VO, and AX, which we know is 0. Delta y, VO, and AY, which we know is negative 9.8 meters per second squared. Now, I'm not going to fill in delta x and delta y just yet. I want to go and find the components of the velocity. It's 20 meters per second. This one ends up being 16 meters per second, roughly, and 12 meters per second. Since this is a 37 degree angle, it's technically a 3-4-5 right triangle. So this is 16 meters per second, and this is 12 meters per second. If you plug it into a calculator, you'll verify that that's fairly accurate. Okay, so again, what I want to do here is to figure out when it's 36 meters off the ground, or 36 meters out from the kicking spot, is it at least 3 meters above the ground? So I have two options here. I can figure out how long it takes for the ball to get to 36 meters, plug that time into the y equation and see how high it is, or do the opposite. Figure out how far, or at what time is it 3 meters off the ground, and then see, using that time, how far away is it. I'm going to do the first one because the time's a lot easier to solve that way. So I'm going to use the delta x equation. And I'm going to say, okay, when it's 36 meters away, how long does it take to get there based on the velocity? So, acceleration drops out. Velocity is 16 meters per second. So the time is what I'm trying to solve for. And I plug in that time. Now, it's possible that it doesn't even make it that far, but then we'll know that the answer is no, it's not going to make the field goal. We get 2.25 seconds. Now, if you would have done delta y first, the time would have been a little bit more difficult to solve for. Could do it, but it's a little more challenging. Now we'll go to delta y. And what we'll do is just figure out what height is it when the time is 2.25 seconds. So we have 12 times 2.25 seconds, because that's how long it's going to take, plus 1/2, negative 9.8 meters per second squared, and times the time of 2.25 seconds squared. So we'll have to plug all this in. 12 times 2.25 is 27, minus 4.9 times 2.25 squared. I'm getting a height of 2.19 meters. I'm going to check it. 12 times 2.25 minus 4.9 times 2.25 squared. Yep. So the football's not going to make it because it's only 2.1 meters, 2.2 meters off the ground when it's 36 meters away. So the person's going to have to move inward. And it asks, well, how far? So basically, we'll do the reverse now.